Thermal energy can refer to several distinct thermodynamic quantities, such as the internal energy of a system, heat or sensible heat, which are defined as types of transfer of energy as is work, or for the characteristic energy of a degree of freedom in a thermal system. K T _KT, where T _T is temperature and K K is the Boltzmann constant. Topic: Relation to heat and internal energy. Heat is energy transferred spontaneously from a hotter to a colder system or body. Heat is energy in transfer, not a property of any one system, or contained within it. On the other hand, internal energy is a property of a system. In an ideal gas, the internal energy is the sum total of the gas particle's kinetic energy, and it is this kinetic motion that is the source and the effect of the transfer of heat across a system's boundary. For this reason, the term, thermal energy, is sometimes used synonymously with internal energy. Heat and work depend on the way in which an energy transfer occurred, whereas internal energy is a property of the state of a system and can thus be understood even without knowing how the energy got there. The term, thermal energy, is also applied to the energy carried by a heat flow, although this quantity can also simply be called heat or amount of heat. In many statistical physics texts, thermal energy refers to K T _KT, the product of Boltzmann's constant and the absolute temperature, also written as K B T _K_B_T. Historical context. In an 1847 lecture titled, "On Matter, Living Force, and Heat", James Prescott Joule characterized various terms that are closely related to thermal energy and heat. He identified the terms latent heat and sensible heat as forms of heat each affecting distinct physical phenomena, namely the potential and kinetic energy of particles, respectively. He described latent energy as the energy of interaction in a given configuration of particles, i.e. a form of potential energy, and the sensible heat as an energy affecting temperature measured by the thermometer due to the thermal energy, which he called the living force. Useless thermal energy. If the minimum temperature of a system's environment is T E _T_E and the system's entropy is S _S, then a part of the system's internal energy amounting to S T E _S CDOTT_E cannot be converted into useful work. This is the difference between the internal energy and the Helmholtz free energy. See also: heat transfer, ocean thermal energy conversion, orders of magnitude temperature, thermal energy storage, thermal science.